Write down work, power and energy. And the first thing we are interested in is work. Well, 10 से आपको वर्क का जो बेसिक डेफिनेशन है वो पता है. That work is what? Force multiplied by displacement. What have you been told? That if we have an object of mass m, and this object of mass m is being pulled by a force of F, and it moves from this position to this position. This is the initial position and this is your final position. Then you can see that its displacement is this much. From this position to this position, displacement is what? S. And therefore, we say that work, the way we have defined work is what? Force multiplied by displacement. That's what you know as of now. That work is force multiplied by displacement. Now, consider this situation. Suppose we apply a force in this direction. And this direction makes an angle of theta with the direction of displacement. It moves from this position to this position. That's the direction of displacement. Under this force, which is acting at an angle of theta, theta is taken from the direction of displacement. Then, in this case, if somebody says that work is force multiplied by displacement, then it will be a wrong thing. If an object moves with the help of this force and displacement is S, and if you write W as F into S, then this is wrong. Why this is wrong? If you take components of F, then you can see that this component in the direction of displacement is F cos theta, whereas this component is F sin theta. This component is F cos theta and this component is F sin theta. These are the two components of force, F cos and F sin. And if I ask you that what is the force which is responsible for this displacement? If I ask you what is the force which is responsible for this displacement, F sin theta or F cos theta, then what's your opinion? Write down what do you think in the comment box. what is the force which is responsible for the displacement? F cos or F sin theta? What do you think? Write that down in the comment box. Good. We can see that this displacement is because of F cos theta, and therefore when you write work, instead of saying that entire force F is involved in doing that work, we see that only F cos theta component is responsible for the displacement, and therefore work is F cos theta multiplied by S. F cos theta multiplied by S. Now, जैसे फिजिक्स में आपने F cos theta into S ये डेवलप किया, तो फिर एक मैथ्स वाला बंदा था, उसने किस चीज को नोटिस किया? उसने नोटिस किया दैट W वर्क is a scalar quantity. Force and displacement, they both are vectors. And if you have two vectors A and B and you take their dot product, if you have two vectors A and B such that angle between the vectors is theta, then A dot B is magnitude of A, magnitude of B, cos of angle between A and B, which is what? Theta. The same thing is happening here. Vector, a scalar, and therefore we can rearrange work in this form: F dot S, F dot S, and that's the format which you remember from now on. There is a difference between F into S and F dot S. This part you can see is valid only if situation is like this. Force and displacement, they both are in the same direction. If force makes an angle of theta with the direction of displacement, if force makes an angle of theta with the direction of displacement, then that's how you answer your work part. F dot S. Note down this much. Now write down a statement. Since displacement in the given figure, since displacement in the given figure has been produced by F cos theta component of the force, F cos theta component of the force when we write work, we must only take F cos theta. We must only take F cos theta, and F sin theta should be ignored. And F sin theta should be ignored. Now, this F dot S, before we proceed, this F dot S, or if somebody writes like this, S dot F, it doesn't matter, they both are same. You can also mention like this. How come? Because A dot B is AB cos theta, which is same as B dot A. A dot B is same as what? B dot A. And therefore, if somebody writes F dot S or he writes S dot F, दोनों का मतलब क्या हुआ करता है? Same. लेकिन यहाँ पर हम अब इस वर्क को डिफाइन करने के लिए किस तरह से एक विजुअलाइजेशन डेवलप करेंगे उसके पास चलते हैं. Although you can see that visualization in this figure, but still, let's develop this whole thing in two ways. Look here. That's the displacement. That's your force. First visualization, you can see yourself, F has been resolved in this direction, giving you F cos theta into S, F cos theta into S. The second visualization is like this. This angle is theta. Then, instead of resolving force, you could also resolve displacement. You can resolve any vector. When you resolve displacement, then component of displacement in this direction, किसी भी वेक्टर का अपने से थीटा पर कंपोनेंट, इस डायरेक्शन का जो कंपोनेंट बनेगा, that will be S cos theta. If this is S cos theta, then we are resolving displacement. In this direction, its component is coming S cos theta. अगर एक कंपोनेंट इस तरफ लिया है, तो दूसरा कंपोनेंट पहले वाले से कहां लेते हैं आप? 90 डिग्रीज पर. That's the other component. This is the direction of other component, which is like this. S sin theta. S cos, S sin. Now, when you look at this setup, work is what? F cos theta multiplied by S. Work is what? F cos theta multiplied by s, which you can rearrange like this. F multiplied by s cos theta. It doesn't matter because these are simple magnitudes, and even if they are not magnitudes in dot, it doesn't matter if you take A dot B or you go for B dot A. The thing is that f cos theta s is same as f multiplied by s cos theta. What is happening? F multiplied by s cos theta. We have ignored what? S sin theta. That means what? This belongs to this category. This belongs to this. And how do we interpret this and this format? अपन उसके पास चलेंगे. Let's call it format 1 and let's call it format 2. Just for namesake, you can say anything, equation number 1 or equation number 2, it doesn't matter. So this is format 1, this is format 2. Mention this much information, draw this figure, resolve the vectors and write down like this, format 1 and format 2, and then we'll use some statements. Now write down the statement for format 1. This first format, let's write down the statement for this. That is for this figure, basically. In format 1, work is displacement multiplied by component of force in the direction of displacement. Component of force in the direction of displacement. Whereas in format 2, work is force multiplied by displacement in the direction of force. Force multiplied by displacement in the direction of force. अब दोनों जगहों पर हो क्या रहा है, दोनों जगहों पर क्या होने लगी ये चीज. आप फर्स्ट फॉर्मेट में बोल रहे हो डिस्प्लेसमेंट, multiply displacement with that part of force which is in the direction of displacement. In second, you are saying that work is what? Force multiplied by that part of displacement which is present in the direction of force. Now, this is the basic thing behind dot product. Dot क्या बोलता है? Dot बोलता है कि आपको हमेशा ऐसे पार्ट्स वेक्टर्स के मल्टीप्लाई करने हैं जिनका डायरेक्शन क्या होता है? सेम. फिर से सुनना मैंने क्या बोला. When you say dot product basically says what? You need to multiply that parts of vectors which are in the same direction. इसीलिए जब हम लोग डॉट लेते हैं तो आपने क्या नोटिस किया था? I is multiplied with I, J with J and K with K. I with I, J with J and K with K. I का J के साथ कोई मतलब नहीं, J का K के साथ कोई मतलब नहीं. यहां हम क्या बोल रहे हैं? अगर आपको वर्क की बात करनी है, then what is work? F dot S. What does it mean? It means that you take those parts of force and displacement, which are in the same direction, which are in the same direction, which are in the same direction. होपफुली समझ में आ गया होगा. वर्क को F डॉट S या S डॉट F इस तरह से प्रेजेंट करने का तरीका. एंड बिल्कुल फंडामेंटल लेवल पर जो आपने 9th-10th में सीखा है वही चीज हो रही है. वर्क अभी भी कितना है? फोर्स इनटू डिस्प्लेसमेंट. And you correctly identified when I drew this figure, you correctly identified that what is that component of force which is responsible for the displacement. You immediately said what? F cos theta. And therefore, when somebody writes work, he shouldn't use F. Instead, he should go for F cos theta. Hopefully, work का dot product representation क्लियर हो गया होगा. नाउ एक बार इतना वर्क का डॉट प्रोडक्ट रिप्रेजेंटेशन अगर क्लियर हो गया है, देन इस वर्क को डिफाइन करने के लिए अब कुछ चीजों के पास चलते हैं अपन. देखना रहेगा. Let's take this simple example and then we'll go deeply into all these thetas and all. हमने प्रोजेक्टाइल मोशन में इस तरह के क्वेश्चंस किए थे कि अपने पास एक बिल्डिंग है, height of the building is h, and when you throw an object with some velocity u, then ultimately it lands right here with velocity v. That's what we have done in projectile motion. You throw an object with speed u and it lands at this point with some velocity v. यहां से यहां तक range was r. Just let me see how active you are. For the range, which equation is correct? U square sine 2 theta upon g. Let's call it first one or the second one. U times root over 2h by g. It has nothing to do with work, just to see your activeness. For this setup, if I go for range, then which equation, which format is correct? First or second? Write down in the comment box. Range is u square sine 2 theta upon g or u times root over 2h upon g. What do you think is the correct version? First or second? Write it down in the comment box. Everybody, what do you think? Only one person so far has correctly answered it. None. Neither this nor this. केवल एक बच्चे ने इस चीज को करेक्टली पिन पॉइंट किया. गुड. बाकी लोग, this is used for ground to ground. That's not ground to ground. This is used for horizontal projection from a given height. It's not a horizontal projection. And therefore, neither this nor this. And how do you find range? Using trajectory equation. यहाँ के कोऑर्डिनेट पता है 0 0. यहाँ के कोऑर्डिनेट पता है r, minus h. You put these coordinates in trajectory equation and you get the answer. तो एक आदमी ने सही पिन पॉइंट किया, बाकी फर्स्ट और सेकंड में कंफ्यूज थे. एक तरह से प्रोजेक्टाइल का रिवीजन हो गया. This is for ground to ground. This is for horizontal projection from height h. दोनों ही केस यहाँ पर इन्वॉल्व नहीं है. I'm not interested in this. मैंने केवल बोला कि पता होना चाहिए था. तो क्या पता होना चाहिए था कि हमारा ये इनिशियल पॉइंट है and this is the final point. Starting point, final point. इस पूरे टाइम जब ये आ रहा था तो इस पर जो फोर्स लग रहा था that was force of gravity, which is mg. Now write down the question. Find out work done by gravity. Find out work done by the gravity for the given object. Note down the figure. आपके पास फॉर्मेट 1, आपके पास फॉर्मेट 2. इसके अलावा कुछ और आपको पता हो आप वो भी यूज कर सकते हैं. दो लोग और हैं जिन्होंने नाम आइडेंटिफाई किया. देखना भाई यहाँ पर पूरी कहानी को देखना क्या हो रहा है यहाँ. अपने को वर्क फाइंड करना है ग्रेविटी का. वर्क डन बाय ग्रेविटी mg. हमने क्या डिफाइन करना शुरू किया. अगर प्रॉपर f.s फॉर्मेट की बात करते, f.s फॉर्मेट की बात करते, तो हम क्या कर रहे होते, mg into displacement into cos of theta. mg multiplied by displacement multiplied by cos of theta. हम यहाँ गए होते. Now what is displacement? What is displacement? Displacement is what? Shortest distance between initial and final points. That's your initial point. This is your final point. Join like this. This blue line, it represents displacement S. work done by mg s cos theta. Now, again, show me that you are actively sitting in the class. Get me cos of theta. We can see displacement. What is displacement? You can see displacement mg from this to this. If I ask you displacement, you would simply write what? R square plus h square. You can simply do that. That's your displacement. H R. Now look at this figure. And what do you think cos theta is? Write down the value of cos theta in the comment box. Write down the value of cos theta in the comment box. Take now. When you write theta, what is theta first of all? थीटा कुछ लोग क्या करते हैं, अगर आपको याद हो प्रोजेक्टाइल मोशन में अपन लोग u का हॉरिजॉन्टल से एंगल लिया करते थे थीटा, तो आदमी उसी थीटा को उठाकर यूज कर लेता है, लेकिन नहीं. When you write theta, what is theta? Theta is the angle between force and displacement vectors. Force and displacement vectors. Do one thing. जहां आपने f cos theta s नोट किया हुआ है या कहीं भी जहां आपके पास जगह हो, मार्जिन में या टॉप में, write down statement for theta. Theta is angle between force and displacement vectors. Theta is angle between force and displacement vectors with their tails joined together. What does it mean with their tails joined together? ये रहा force mg, ये है displacement. आदमी यहाँ पर थीटा फाइंड करने में कंफ्यूज होता रहता है, क्या है थीटा? mg, displacement. What I am saying is, once you find force and displacement, कहीं भी हो, collect them and join their tails together. That's how you find theta. Displacement, force, दोनों को लेकर आओ, tail join कर दो. That's the theta. Which means what? इस सेटअप में this is mg and this is displacement, and therefore we are interested in this theta. Mg this. What is theta? Angle between vertical line and this inclined direction of displacement, which is this. That's your theta. Now if you look at this right angle triangle, then in this right angle triangle, you can see what is cos theta. Cos theta is base h. Hypotenuse is what? S. H divided by S. What is cos theta? Now, to keep it simple now, let me remove this root over r square plus s square part. Let's get rid of it. Let's write down simply s multiplied by cos theta, which is coming h upon s. S cancelled. This is coming mg multiplied by h. Work done by mg for this parabolic path is mgh. Note down everything in this part. Don't forget to draw this figure. ये आपको बाद में याद दिलाएगा कि थीटा के लिए सबने क्या बोला हुआ था. अब instead of doing this whole exercise like f dot s, mg has cos theta and all, अपन चलते हैं फॉर्मेट नंबर 2 के पास. If somebody is using format 2, तो ये क्वेश्चन कितना इजी बन जाता है उसके लिए. ये क्वेश्चन कितना इजी बन जाता है देखना. अगर किसी ने बात की होती वर्क फाइंड करने की, let's go for second method. We are interested in the second method. What is the second method? Look here. We need work. जो फॉर्मेट डेवलप किए इनका क्या फायदा है उसकी तरफ चलते हैं. वर्क फाइंड करना है. किसका वर्क फाइंड करना है? mg. इसका वर्क फाइंड करना है mg. What is format 2? Format 2 says work is what? Force multiplied by displacement in the direction of force. Remember this. Force multiplied by displacement in the direction of force. Now when this object moves from this position to this position, whatever be its path, if I ask you what is displacement in the direction of mg, what is displacement in the direction of mg, that means I'm basically asking you what is displacement vertically. mg का direction क्या है? Vertical direction. When I say that force multiplied by displacement in the direction of force, तो वो यहाँ किस फॉर्म में कन्वर्ट हो रहा है? Work done by mg is what? mg multiplied by that part of displacement which is in the direction of mg. What is that part? Displacement has two parts, h and r. इसमें से कौन सा part mg के डायरेक्शन में है? आपने बोला h, and therefore in just one line you can answer mg multiplied by h. सेम चीज रही है, लेकिन in just one line using format 2 you could answer this question. Now write down second method and then जैसे जैसे मैं बोलता हूं उस तरह से चीजों को नोट करना. Second method, work done by mg is mg multiplied by displacement in the direction of mg. mg multiplied by displacement in the direction of mg. And in the next line, simply write down this. Wmg therefore is what? mgh. Wmg is therefore mg multiplied by h. Like this. Hopefully समझ में आ गया होगा क्या किया हुआ है हमने यहाँ पर. That's your second method. Second method में हमने किसकी help ली हुई है? The second format. Okay, just for your understanding, you can also write down that with the help of format 2. बाद में आपको याद रहेगी हमने इसके लिए क्या यूज किया है? The second format. Now, let's go for a third method. Third method for finding work is using I cap and J cap. Let's just, I will give you 1 minute's time. Let's see how many of you can proceed after this hint. In third method, I need work with the help of I cap and J cap technique. You will write force, you will write displacement in terms of I and J. You will take the dot, and once you get mgh using I cap and J cap and dot, once you get mgh, write down yours in the comment box. Let's see how many of you can do it. Write down third method with the help of I cap and J cap. And let me see how many of you can answer this question. Signaling. Force. कितना है force mg? And what is the direction of mg? Downwards. Downwards means minus of j cap. That's your mg. Minus j cap. Now let's go for displacement. Displacement के साथ कहानी क्या बनी हुई थी? Displacement के साथ कहानी ये बनी हुई है. We have got h, then we have got r, and this whole thing is the displacement. H or that's your displacement. If this is displacement, then displacement is what? H किस तरफ? Minus of j cap, minus j plus r, ये किस तरफ? I cap. What is displacement in vector form? H downwards minus j plus r I cap. Then what is work? हमने बोला work is F dot S. Work is F dot S. F dot S. And how do you go for dot product? Dot का मतलब क्या होता है? I with I and J with J. इस सिचुएशन में कहीं कोई I नहीं है, कहीं कोई I नहीं है, ये समझने के लिए आप इस तरह से मेंशन कर सकते हैं, प्लस 0 I cap. There is no I present and therefore I said 0 I cap. When you multiply, you get what? You get R multiplied by 0 plus I with I with I and J with J, MGH. हाँ, मैंने इंटेंशनली इसको R into 0 करके बनाया है, इससे कि थोड़ी देर बाद कोई चीज आएगी वो आपको समझ में आ सके. क्या किया हमने? I with I, J with J, minus minus plus mg into h, and ultimately जो आपका work आ रहा है, this work is coming mg multiplied by h. Everybody note down like this. आपने कैसे भी निकाला हो, I want you to write down things like this. That's your third method. Note down this much. तो हमने इतनी सब कहानी क्यों बनाई हुई है जरा? Apart from developing work, let's also go for जहां हम इस वर्क का यूज करेंगे, write down work energy theorem. Write down work energy theorem. Write down a statement. Work done by all the forces. Work done by all the forces on a system. Work done by all the forces on a system is equal to change in its kinetic energy. Is equal to change in its kinetic energy. क्या statement है अपना? Work done by all the forces. Work done by all forces. It does what? It is delta K. I hope you know what delta is. Delta means change. Change in kinetic energy. That's a statement of work energy theorem. जितने भी आपने work किया, that all work goes into what? In changing kinetic energy of the system. What is this delta K? You can also write delta K as K final minus K initial. Write out like this. Delta K, and then delta means change. Change means final kinetic minus initial kinetic energy. Now, let me see how many of you can find V for the given question. V in terms of U, H, R, theta, mg, whatever जो भी आपको और चीज दिख रही हो, find out V when object hits the ground with the help of work energy theorem. And once you find it, do write it in the comment box. I want you to find V in terms of all these things which you see on the board. जैसे जिसकी आपको जरूरत हो उसको रखना, जिसकी जरूरत नहीं है उसको हटा देना. This is R. To find out V when this object hits the ground using concept of work and this work energy theorem. It's a very simple statement. जितना आपने वर्क किया वो क्या करेगा? सिस्टम की जो काइनेटिक एनर्जी है, and I hope everybody knows what kinetic energy is, half n velocity square. And that will show you the beauty of this work and all concept which we are doing. Why we took interest in work energy and all. What was the need of work? What was the need of work? Because if you remember, I don't know if you remember, we have developed V in projectile motion. We have developed V in projectile motion. How we did that? We resolved this U in projectile motion. What we did? We resolved this U in horizontal component and vertical component. And then we used to say, whatever happens, horizontal component of U never ever changes. And therefore, when it hits, you keep the horizontal component intact. For the vertical component, you go for V square equals U square plus 2AS in the vertical direction. That's how you find Vx and Vy. And then the vector form of V is root over Vx square plus Vy square. If you remember, that's what we did in projectile motion and we obtained V. Now I want you to find this V with the help of work energy. I've only got 4 or 5 responses so far and only one of them is correct. 2 are correct. The इससे इजी चीज पूरे फिजिक्स में नहीं मिलेगी भाई, सब कुछ सामने है, सब कुछ सामने है। क्या है सब कुछ सामने, देखना है इधर। चलो क्या फाइंड करना है अपने को, वर्क डन बाय ऑल द फोर्सेस। जो आपने इसको यहां से रिलीज किया यहां तक एक ही फोर्स है जो लग रहा है, कौन है वो, mg। वर्क डन बाय mg, देखना भाई। फॉर द इंटायर पाथ, for the entire path there is only one force which is mg। जो भी वर्क है वो करता क्या है, it changes kinetic energy। ke final minus ke initial। what is work done by gravity, m g h। here what is ke final, half m v square minus half m u square। initial final v, m cancelled, v shift this side, multiply by 2, n is cancelled, take root। इतनी मैथ बनती होगी भाई। v is coming root over u square plus 2gh। shift, cancel n, multiply by 2, take the root, that's your v, which is coming root over u square plus 2gh। इसी रिजल्ट को प्रोजेक्टाइल में लाने के लिए क्या करना पड़ता, मैंने बताया, कंपोनेंट्स लेने पड़ते। एक्स डायरेक्शन को अलग से हैंडल करो, वाई को अलग से हैंडल करो, देन v का वेक्टर सम निकालो। यहां हमने क्या किया, वर्क डन बाय mg, कितना है, mg into h, mg multiplied by displacement in the direction of mg। ये वर्क गया कहां, ये सारा का सारा वर्क जो mg ने किया उसने इस ऑब्जेक्ट की काइनेटिक एनर्जी को इंक्रीज कर दिया। That's the increase in kinetic energy and you got v in just one line, root over u square plus 2gh। अब ये जो चीज इधर से संभाल कर रखी हुई है उसको देखना, ये जो चीज संभाल कर रखी हुई है, you can see that r is getting multiplied by 0। बोर्ड पर देखते हैं ना, r is getting multiplied by what, 0, and therefore it doesn't matter where it lands, it doesn't matter। यहां अगर आपने h हाइट से ऑब्जेक्ट को थ्रो किया u स्पीड से and it lands here with velocity v, एक दूसरा आदमी आया, दूसरे आदमी ने इसको u से इस तरफ प्रोजेक्ट किया and it lands here, then at this stage again speed will be v। अगर यहां v से हिट करेगा तो यहां भी v से हिट करेगा। आपने एंगल ऑफ प्रोजेक्शन चेंज कर दिया है, you have changed angle of projection and that change in angle of projection has changed your r, from r1 it becomes r2, from r1 it becomes r2। इसी तरह से ड्रॉ कर लेना फिगर को, इसी तरह से, but you can see that r is multiplied by 0, का कोई इंपॉर्टेंस नहीं है। किसका इंपॉर्टेंस है, h। आप ब्लैक पाथ कंसीडर करो या फिर आप ब्लू पाथ कंसीडर करो, दोनों केस में वर्टिकल डिस्प्लेसमेंट केवल कितना है, h। and therefore ये भी V है और ये भी V है. And I hope you remember this thing from projectile motion. Projectile motion में अगर आपको याद हो तो मैंने इस तरह के 3 पाथ बनाए थे और उन 3 पाथ को बनाने के बाद मैंने आपसे पूछा था what is the ratio of V1 is to V2 is to V3. If you remember that, if you do not, जाकर देखना तो आप उसको और अच्छे से समझ पाओगे. एक हमने ऊपर की तरफ थ्रो किया था, एक हॉरिजॉन्टली थ्रो किया था, एक नीचे की तरफ थ्रो किया था और मैंने पूछा था कि किसकी स्पीड ज्यादा होगी. एंड अल्टीमेटली व्हाट वी फाउंड, तीनों जब हिट करते तो उनका स्पीड क्या आता, सेम. क्यों आता? आर का कोई रोल नहीं है. Draw each and everything in this form. ये भी V, ये भी V. Put down this much. How could you consider U as 0? If somebody throws this thing with U equals to 0, then there is no projectile motion. It will simply land vertically down. Hopefully ये पूरा setup clear हो गया होगा. An importance of finding work. Again, look at the importance of this work approach. मैंने आपसे बोला कि इसी कहानी को प्रोजेक्टाइल में भी हमने डेवलप किया था, लेकिन प्रोजेक्टाइल में जब हम डेवलप कर रहे थे तो हम लोग ये सब करते थे. V equals to U plus AT. X, X, X. And then we used to go for Y, Y, Y. Because these are Newton's equations, and in these Newton's equations we are dealing with vectors. Velocity vector, initial velocity vector, acceleration. Vectors में आपको हर चीज का दिमाग में ध्यान रखना पड़ता है, डायरेक्शन एंड ऑल सारी चीजों का. लेकिन यहां हम किसकी बात कर रहे हैं? वर्क. What is work? Scalar quantity. Kinetic energy, scalar quantity. आपने इस तरफ थ्रो किया है या इस तरफ थ्रो किया है या इस तरफ थ्रो किया है, it doesn't matter. Kinetic energy half mu square, half mu square, half mu square. दोनों केस के लिए काइनेटिक एनर्जी क्या रहेगी? सेम. दोनों केस के लिए स्पीड सेम है, लेकिन इन दोनों केस के लिए वेलोसिटी सेम नहीं है. वेलोसिटी क्या होती है? वेक्टर, मैग्नीट्यूड as well as direction. And therefore, when you use these equations, you are dealing with vectors. जब आप इस चैप्टर पर आते हो तो आपने क्या किया? उन वेक्टर्स को एक टेक्निक डेवलप की और उन वेक्टर्स को आपने किस फॉर्मेट में कन्वर्ट कर लिया है? स्केलर फॉर्मेट. वेक्टर्स को कन्वर्ट नहीं किया, एक नई चीज डेवलप कर ली है which is a scalar thing. And therefore now you don't have to worry about direction part. ये V से ऐसे टकरा है या ऐसे टकरा है या ऐसे टकरा है, it doesn't matter. Kinetic energy is always what? Half m V square. Now, इतना करने के बाद इस एग्जाम्पल एंड ऑल से अपने को वर्क का एक अच्छा खासा आइडिया लगना शुरू हो जाता है एंड देयरफॉर अब अपन कुछ चीजें हैं जो इससे रिलेटेड उनको समझ सकते हैं. Let's go back to that fs cos theta part. So fs cos theta में हम लोग कुछ चीजें इनको समझना चाहते हैं. Write down again relationship of theta. Write down the adding relationship between theta and work. Relationship between theta and work. थीटा का मतलब ध्यान रखना, थीटा कोई भी थीटा नहीं है. थीटा इज एंगल बिटवीन फोर्स एंड डिस्प्लेसमेंट. हम उसकी बात कर रहे हैं. Now write down case 1. In case 1, write down angle between force and displacement. Angle between force and displacement is acute, less than 90. Angle between force and displacement is acute, less than 90. Case 2. Case 2. Angle between force and displacement is 90. Case 2, angle between force and displacement is 90. Case 3, angle between force and displacement is obtuse. Angle between force and displacement is more than 90 or obtuse. This is case 1. This is case 2. This theta you can see is less than 90. And case 3, in case 3, you've got displacement and force is acting like this. Angle between force and displacement is theta, which is greater than 90. In तीनों cases में work, आपको क्या define करना है? आपको क्या define करना है? You need to choose out of these three options. Is it positive? Is it negative? Is it zero? And then you will write that in that sequence. अगर आपको लगता है कि positive, 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 then write down positive, positive, positive. If you're saying negative, 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 write down that. Positive, negative, zero, write down that. Draw this figure and write down the answer in the comment box. All three cases, 1, 2, 3. What is the work? देखना भाई, अपना वर्क क्या हुआ करता है, एफ एस cos थीटा, मैग्नीट्यूड पॉजिटिव है, मैग्नीट्यूड पॉजिटिव है, इससे बात कर रहे हैं अपन लोग cos थीटा से। For acute angle, you know that cos is positive, work आएगा positive. If theta is 90, everybody knows that cos 90 is what? 0. When you have got obtuse angle, theta is obtuse, obtuse के लिए cos की वैल्यू शायद याद हो, obtuse के लिए cos की वैल्यू क्या आया करती है? नेगेटिव, positive, 0, negative. That's the reason, that's the logic for this coming from for these different categories of theta. अब this was very easy or simple thing. अपन जिस चीज में इंटरेस्टेड हैं, हम क्या सीखना चाहते हैं, with the help of this, अब वहां चलते हैं. Who will tell me the meaning of negative work? What is the meaning of negative work? You can switch on your mic and tell me. What is the meaning of negative work?
Sir, the direction of F and S.
So, basic meaning. Work is a scalar quantity.
Decreasing of kinetic energy.
That's the statement. That's a good statement. Outside. Write down this. When you see work as positive and negative, लोगों को लगता है east, west. नहीं. When you say work is positive, work is negative, you are dealing with a scalar quantity. Work is scalar. For scalars, if you say plus and minus, तो इसका मतलब क्या होता है? Vectors में plus and minus का मतलब क्या होता था? Basically, plus and minus होते ही क्या है? When you have got two things, when you have got two aspects, one aspect is called positive, the other one is called negative. If you have only two possibilities, if you have only two aspects with a certain quantity, for example, if you toss a coin, either you get head or you get tail. If somebody says head is positive, then tail is what? Negative. There is nothing vector related in this part. For vectors in one-dimensional path, either you can move east or you can move west. Somebody says that, let's take east as positive, then west is what? Negative. That's how positive and negative signs you define. You've got two types of charges. One is positive charge, other one is what? Negative charge. ऐसा कुछ नहीं है कि प्रोटॉन के ऊपर प्लस साइन लगा हुआ है और इलेक्ट्रॉन को अगर आप जूम करोगे उस पर नेगेटिव साइन दिखेगा. नहीं, ऐसा कुछ भी नहीं है. There are two possibilities. एक को हमने बोल दिया पॉजिटिव, दूसरे को क्या बोल दिया? नेगेटिव. अब वर्क है क्या? वर्क इज व्हाट? चेंज इन काइनेटिक एनर्जी. अगर आपने वर्क ऐसा किया है कि काइनेटिक एनर्जी इंक्रीज हो रही है, दैट मीन्स पॉजिटिव. अगर आपने वर्क ऐसा किया है कि काइनेटिक एनर्जी डिक्रीज हो रही है, देन यू से नेगेटिव. एंड आई होप यू नो कि जीरो का मतलब क्या होगा. राइट डाउन दिस. तो अपन ने यहां पर क्या किया? इंक्रीज मतलब पॉजिटिव, decrease मतलब negative. There are two aspects, increase and decrease. Write down this thing. When we say that work is positive, when we say that work is positive, it means kinetic energy is increasing. It means kinetic energy is increasing. When we say that work is zero, it means kinetic energy is decreasing. When we say that work is zero, it means kinetic energy is decreasing. And when we say that work is negative, when we say that work is negative, it means kinetic energy is decreasing. When we say that work is negative, it means kinetic energy is decreasing. Now, I will take one more minute. देखना, इस सारी चीज को हम जानते थे, लेकिन हमने बोलने का अपना तरीका चेंज कर दिया। हर आदमी को ये चीज पता है कि किसी भी वेक्टर का वेलोसिटी वेक्टर को अगर उसी के डायरेक्शन में फोर्स लगाओगे, हर आदमी को पता है कि वेलोसिटी के डायरेक्शन में फोर्स लगाओगे, देन वेलोसिटी इज गोइंग टू इंक्रीज। इसका मतलब इंक्रीज। हर आदमी को पता है कि अगर आप वेलोसिटी के ऑपोजिट फोर्स लगाओगे, opposite, in that case velocity is going to decrease. हर आदमी को पता है जिधर जा रहे हो उधर ही फोर्स लगेगा, वेलोसिटी इंक्रीज करेगी। जिधर जा रहे हो फोर्स उसके ऑपोजिट है, वेलोसिटी क्या करेगी? डिक्रीज। नाउ लुक हियर, ये जो सेटअप है एफ और थीटा का, इस केस में एफ का एक कंपोनेंट लेट्स कॉल इट एफ एक्स फॉर द टाइम बीइंग। This component fx is in the direction of displacement. That means in the direction of velocity. जिधर जा रहा है उसी तरफ क्या होगी? Velocity. Look at this. इस केस में f के जब कंपोनेंट करोगे, एक कंपोनेंट इधर आएगा. That's the component. This component is what? fx. X direction वाला. And you know that किसी भी वेक्टर का अपने से 90 पर कितना असर होता है? इसे 0 cos 90। इसलिए ये वाला फोर्स आपसे पूछा गया होता कि भैया ये फोर्स डिस्प्लेसमेंट की तरफ कितना इफेक्ट प्रोड्यूस करेगा, तो आप बोलते कोई इफेक्ट प्रोड्यूस नहीं करेगा। किसी भी वेक्टर का अपने से 90 पर कोई कंट्रीब्यूशन नहीं होता। इसलिए इस केस में F का कोई कंट्रीब्यूशन नहीं है। वर्क इज व्हाट? 0। इस सिचुएशन में F का ये जो कंपोनेंट था Fx, ये वेलोसिटी को सपोर्ट कर रहा है, इसलिए वेलोसिटी क्या हो रही है? इंक्रीज। वेलोसिटी इंक्रीज होगी तो काइनेटिक एनर्जी भी क्या होगी? इंक्रीज। पॉजिटिव आ रहा है। अगर ऑब्ट्यूज एंगल है तो ऑब्ट्यूज का मतलब है फोर्स का जो कंपोनेंट है वो वेलोसिटी के ऑपोजिट लगेगा। वेलोसिटी के ऑपोजिट, दैट मींस वेलोसिटी क्या होगी? डिक्रीज। काइनेटिक एनर्जी क्या होगी? डिक्रीज, एंड देयरफॉर दिस थिंग बिकम्स व्हाट? नेगेटिव। तो ये जो डायरेक्शनल स्टेटमेंट्स थे वेक्टर से रिलेटेड, वर्क ने बोला हटाओ इन सबको, अपन इन सारी चीजों को कि कौन किसके डायरेक्शन में है या नहीं है खत्म करके सीधे सीधे क्या बोल देंगे? अगर वर्क पॉजिटिव है इसका मतलब क्या है? काइनेटिक एनर्जी क्या हो रही है? इंक्रीज। 0 कोई चेंज नहीं हो रहा। नेगेटिव, दैट मींस काइनेटिक एनर्जी इज व्हाट? डिक्रीजिंग। फंडामेंटली क्या हो रहा है तो मैंने आपको यहां पर समझा दिया। होपफुली ये चैप्टर आपको यहां तक का पार्ट समझ में आया होगा। बाकी नेक्स्ट क्लास में। थैंक यू वेरी मच।